Cool. So you guys heard a little bit about GraphQL already. So you might have seen a comparison of that to other API technologies, querying technologies. The thing I'm really excited about personally is how GraphQL can be actually a totally new way to communicate between front and back-end developers. So to start, let's go do a little bit of history lesson. You guys have all, oh, come on. Okay, that's not gonna work. You guys have all seen this stuff before, but basically, how did we get to where we are today with modern applications? So back in the day, maybe 5 years ago, we would actually render HTML on the server and send it back to a web browser, and that's the thing you would use to interact with most of your applications. And then next, for performance reasons, instead of sending HTML, we started sending data to a lot of applications and rendering them on the client, and that led to a better user experience. And then life got overall more complicated as we had to support multiple platforms for our applications, both web and mobile, possibly multiple different mobile apps and platforms like tablet, stuff like that. And then again, as the trends move forward and you want to use different technologies for different types of workloads, maybe different databases, so you might have ended up moving to a microservice-based approach where you have lots of different APIs potentially owned by different parts of your organization. And this could lead to some performance issues. For example, you can imagine if you want to render some kind of feed, you might have to get the feed from one service that does the learning for the feed and get the actual items from somewhere else, and you would end up with some sort of number of round trips to render your initial UI, which is not great. So you would end up potentially adding an API gateway in the middle. And so I would say a lot of large organizations, their apps either look like this or the slide before, depending on whether or not they have an API layer in the middle. And the purpose of my talk is mostly to explain why in the future you will actually be writing this API gateway in GraphQL and not as a REST API like you might be doing today. And the reason is it combines the best of both worlds of the approaches that we just talked about. So first, let's go over some possible team structures that you guys might have encountered in your organizations. You might have full stack developers in your organization, people who build both the UI and they build the API that backs that with data. You might have a separate API team, people who manage communicating between the microservices and the front end. You might have the backend services team or teams building the API for the front end developers. This is especially probably a common thing if your front-end devs are writing native mobile code because Swift and Java might be really different from Rails or Node or whatever people use for their API servers. You might also have feature-oriented teams. In any case, there's some different types of people and organizations that all need to work together to make this API thing work out. There's a couple of trade-offs you can make here. For example, the farther you move towards the back-end team building the API or the front-end team building the API, you might end up with different problems. If the backend team writes it, you might take a long time to write the API endpoints that you need for different parts of your user interface or your public API. If the front-end team is developing the API, you might end up with an API that's inconsistent because different front-end people need different types of data. They might quickly prototype a feature and add an endpoint, and then that gets shipped in production, and so you have many endpoints that are serving more or less duplicate data. It's also possible that you'll end up with some performance issues as different data is loaded in many different ways, or the same data is loaded in many different ways. So how can we get the best of both worlds? Something where you have a principled API that sits well with the backend developers and is efficient, but also gives the front-end engineers the tools that they need to access the data they need when they need it without having to wait for people to build new API endpoints. And so that's the goal of GraphQL in my mind, or the biggest thing that I think it brings to really supercharge your workflow in a big organization with lots of different data sources and clients. Let's go back to the basics for a second. I don't know if all of you have, actually, quick question, how many of you people have heard of GraphQL before and have looked at it? Okay, that's maybe about a half to a third. So that's pretty good. It's definitely catching on. You might have heard of GitHub's public GraphQL API announcement a month ago, so people are getting pretty hyped about GraphQL. But let's just go over some of the basic benefits you get from having a GraphQL API instead of a REST API. So you might have seen an example of a GraphQL query. This is a really simple one. The first thing that comes out is that the query looks very much like the response. So instead of in a REST API where you would just send a URL with some parameters and you'd get back an arbitrary blob of data depending on what the server implemented, here you specify the fields that you wanted with some arguments, and you get back a JSON structure that matches the query that you sent. And rather than being a query language like SQL or something like that, where you have unlimited power, GraphQL is an API, so you explicitly declare the fields and the arguments that are available to the front end or API consumer to query. It supports a lot of other really cool stuff that we won't get into here, like computed fields, parameters, type conditions on different types of data to get different fields, and more. And it's also really cool that it validates the queries for you, so you can't end up with an invalid request in some way or sending a parameter that's not used. On the other hand, for the backend developers, the really cool thing is that it has potential for a lot better performance. So because you get all the data requirements up front, you can have one query that's requesting nested data, which means you can plan ahead to what data you need to fetch instead of having multiple REST API calls to get those combined blobs of data. You only ask for the fields that you actually need, which means that you don't have to fetch potentially expensive stuff that the UI is not even using. You can look at all the requirements up front and batch them so that you do fewer reads from your database or your cache. And on the client, there's a lot of fancy tools like Apollo and Relay that will let you integrate with your UI more easily and write your queries declaratively and have them show up basically automatically. So those are just some of the core benefits you might get from GraphQL. But really the most exciting thing to me is there's a lot of technologies before that have claimed to be replacements for REST APIs. And I think GraphQL is probably the first one that I would really believe, saying people are going to stop using REST and they're going to start using this thing, because it's not just a tool or a library or an implementation, it's an open source specification that has implementations in almost every single server-side language that you might be using, and there's more on the way. There's clients for almost every kind of front-end technology you can think of. And just in the year and a half since it's been open sourced by Facebook, who initially invented it in 2012, they released it in 2015, I guess. There's all kinds of editor auto-completion tools for these queries, validation tools, data mocking tools, performance analysis, everything you might want, and a lot of things that are simply not possible with previous generation of APIs. The other really cool thing is it's constantly improving because it's a specification, not an ad hoc kind of set of conventions. You can add new features to this. For example, there's proposals for real-time subscriptions that will let you get new data in response to pub-sub events. There's also a proposal for a feature that I really like personally called defer, which says, okay, you sent this really big query for a bunch of data, but you want to render the initial UI as fast as possible. So you want to get just the newsfeed posts first, and then the comments will come in later. But the server is aware of all the requirements ahead of time so that it can queue those up without having to wait for additional round trips from the client. So just to summarize with this catchy diagram of a brick wall, it seems like between the user interface and the backend, you had to implement a bunch of stuff on the server often to make your UI efficient. You would have to tell somebody else or tell yourself next week, write a note to add a new API feature, and then you would end up hard coding special endpoints for different parts of your UI or different platforms. And with GraphQL, it becomes very simple. Maybe it's overstating it a little bit, but you simply just ask for the data that you want, and then you get it. And there's a description of the data that you're allowed to have. So the focus of my talk here is how can an API technology actually be a tool for communication, right? It's a query language, it's an API technology, it's not like a messaging app. But I think having better technologies that let people have more transparency into what they're doing with an API is critical to make it so that you kind of grease the gears between the front end and the back end development, even if it's the same person. Let's start with the back end point of view. So I think if you look on the internet, you'll find a lot of stuff praising GraphQL from the front end perspective of how easy it is to fetch the data. But even from the back end point of view, like how cool would it be, when you're developing the API to know exactly for every single field you're fetching from your database, know exactly which part of your UI is using that, how are they using it, how often are they using it, who wrote the code that fetches that. And so you can easily, with GraphQL in your API server, have a tool that looks at the inbound queries, looks at the fields that are in there, and generates you some stats that say, well, your mobile app v3 is using this field, but v5 is not using it, and maybe for this other field, nobody's used it since 2015, and so you can safely get rid of it depending on how much you care about backwards compatibility. We on the Apollo team are really interested in building tools to help streamline adoption of GraphQL. So this is actually one of the features that we focused on, a tool we're working on called Optics. So I won't focus on the tool in the presentation, but if you're interested, you can come talk to me after. But basically, this is exactly what it does. You can instrument your server, and you can see an explanation of exactly what fields in your API are getting used. And if you instrument your code with some static analysis, which is also easy because of the shape of the queries, you can actually get a link directly to the source code of the part of the app that is doing that query, which is something that is just like totally next level. Another really cool thing is about API versioning. So instead of saying like, okay, we have the simple version of this endpoint, we have the detailed version of this endpoint, you can just add fields as new clients need them, and you don't have to remove old fields because they're not incurring any problems on the old clients. Whereas in some APIs, the more data you add to the response, the more the old clients are going to get slower because they're loading stuff they don't actually need. And that also often saves you from having a versioned API where you have to totally redirect people to different servers depending on where they came from. Just a simple diagram, basically. You can see that in the new version of our GraphQL API, we've added a whole type and some fields, but it doesn't necessarily affect anybody who is using the old version because they just don't care about those new fields. And so, yeah, from the front-end point of view, you get a lot of insight into how people are actually using your API, which lets you put a lot more into optimizing it and understanding what you need to do to improve it for your consumers, which is really why the API exists. It's so that you can build the consuming things of the API, not just for its own sake. From the front-end point of view, there are also tons of great benefits, right? Because you have this language to specify your data needs. You can basically make your own endpoints at will. You can prototype a lot faster. So where you might before have needed to talk to somebody, say, okay, we'll get back to you next week with the new endpoint that we created, and then you can build your UI. You can prototype super fast. You can even mock out parts of the fields of the data you don't even have yet, and then come back to that later. There's also a performance aspect from the client side. So just like on the server side, you might want to know who's using the fields in the API and what for. On the client side, I think it would be really cool. I'm mostly a front-end developer. I think maybe not a common thing at this conference. But as a front-end developer, it would be cool if I had agency over how fast my UI is. Because often you call an endpoint, like you call the GitHub API in the REST version, and you're like, okay, this endpoint takes 300 milliseconds. Like, I guess that's the lower bound for how long it's going to take to render my data. But what if you knew exactly which parts of that API request were slow and which ones were fast? So for example, just by looking at the query, it might not be necessarily clear that the weather field on somebody's user, for some reason, is querying an external API that takes a long time to respond. And if maybe you don't actually need that field that much in your UI, or you might want to defer it, and that makes the initial round trip time much faster. Coincidentally, also a feature in this tool that we're working on. So we can talk about that later if you guys are interested. Another thing that's really cool, this is like the best GIF of all time or something. So this is an open source tool for GraphQL called Graphical, a pretty clever name, which was built around the same time as GraphQL was open sourced, which is the kind of thing you often only get with a backend as a service. Like you might be, I talked to some developers who are using Firebase, and they're like, this is so cool, I can just explore the data in Firebase really easily. But now you can get a similar experience because of this great GraphQL specification that gives you a description of your API. You can have open source tools talking to your in-house open source backend that give you the kinds of features you would previously only expect from a hosted service. And this is just the start. There's actually a plugin now that I'm super hyped about that will give you this experience inside IntelliJ. And there's other plugins that people are working on to give you the same thing in Atom or Sublime Text. So your UI developers will never send an invalid request again, and you actually don't even need like a documentation page for your API anymore. You have autocomplete across services, which is pretty crazy. If I had to summarize how this feels to me whenever I talk about it, it's like before, whenever we had devices, we would have to build physical buttons and interfaces for people to be able to accomplish exactly the thing that they need, right? You would have a phone, and you have to dial a number, wait until it comes back, and dial another number. But now we have touchscreens, and that's one of the things that's unlocked cell phones to be way more powerful and basically mold themselves to the exact need you have at the moment. And that's kind of how I feel about GraphQL as an API technology versus some of the previous ones I've used. So, we've talked a little bit about how GraphQL can benefit communication between the front end and the back end and grease those gears a bit. One of the things it does is enables a couple of new API workflows, you might say, ways that a team might even build an app using these kinds of APIs. So, I don't know, this is definitely what I did in college, but they were like, step one, design your database schema, build a diagram with all the rows and the types, put some arrows between them. And I've definitely looked into some meetings of our production services team where they've been drawing some diagrams like this. The problem is the database schema is not always super relevant to front-end developers. And that might not be a super big problem, but the thing that's definitely a really big problem is today, not all of your data lives in one database. As we heard before, you have all kinds of different caches, backend services, APIs, maybe you have different databases for different needs. This diagram gets super complicated if you had to draw one part of the diagram for SQL and one part for Mongo and one part for Redis. So what GraphQL has is it has a schema definition language which describes not your backend database, but your API. So the same way you might describe a REST API with one of those languages like RAML or Swagger, in GraphQL, you end up describing your API and building it in one step. So not only can you use this as a design tool, it's kind of a well-specified language, but you can actually use this language to implement your server. You can start by taking this language, passing it into one of the many GraphQL libraries, end up with a mocked server that will just spit out random stuff of the correct type, and then fill in implementations for those fields over time to get your real backend. The developer workflow overall looks like this. So when we were building that optics product I was talking about that we're going to be releasing soon, this is kind of how it went. The UI developers and the API developers sat together. They ran a schema in the GraphQL definition language. They put it up on the projector screen. The UI developers built a thing that mocked out the data. They attached some GraphQL queries to their React components that returned data of the correct type, but it looked weird and fake. But that's fine because they got to build the UI immediately. Then the API developers came out and built out the schema, and then at the end they glued them together. And of course, there's a couple of things that are not quite the same, but it pretty much just worked. And then because these queries, at the end of the day, when you ship your app, the queries are static. You can actually optimize the performance of the individual queries and use that to get around the dynamic nature of the API a little bit. So in development time, GraphQL can be totally dynamic. But in production, you can actually save those queries and not let people execute arbitrary stuff against your backend, which is definitely a concern people have when they first see the technology. And then you're done, and you can build a whole product in half the time or something. Two conclusion slides. First one, GraphQL will just make developers happy. On the back end, it's a clear and concise API because you get to actually describe the data you have, not describe a list of endpoints that matches the consumer's needs. And you know how people are using the data because you can inspect what fields are in the queries they send. You don't need to change your endpoints frequently in response to small changes in the UI and optimizing small efficiency things. And it turns out the security surface area is actually smaller because you don't have all these different endpoints that are being implemented by different people for different needs. And paradoxically, it's also great for front-end developers because you can easily consume the data with crazy cool developer tools. There are all these libraries you can use to integrate with every UI layer you want to. And you can build your own endpoints without actually writing any code. And for communication, you put these things together. You can use the shared type language to actually understand the data in your organization, right? You can I've heard of organizations, before they were using GraphQL, they had different words for the same thing. Like one thing would call something an account, the other people would call it like some other account-related term, I don't know, like finance stuff. But they would use different words, but now that you have this shared schema that both the UI developers and the backend developers are looking at, you can use the same word to refer to the same object. Clear API design process that you can follow to get that app built. Self-documenting, UI developers get to know about performance, and API developers get to know about how their API is being used. So that's about all I had to say about GraphQL today. I hope you guys are pretty excited about the idea of making it super easy for your front-end developers and back-end developers to work together, and thank you. So if you want to learn more, just check out some of these links. GraphQL.org recently got redesigned. Super sweet now, has all these really great animated diagrams. They're really cool. Anyway, if anybody has any questions, I'd be happy to answer them.
Thanks for your hard work with GraphQL. We adopted it widely this year all over the place. There's an active discussion on the public on a Grape API project, which is a Ruby API layer. People wanting to add a GraphQL layer on top of the API itself and not as a choking point to aggregate multiple APIs and stop doing like HAL or other hypermedia type things. How do you feel about that? Making that the API layer of an individual API.
You're saying for like an individual microservice?
Yeah.
Yeah, so I guess the question is, I've been talking mostly about GraphQL as an API gateway between any number of different backends and your UI specifically. What would it be like to use GraphQL as the API for the microservices themselves? So just completely eliminating other kinds of APIs in your architecture. That's one thing that hasn't really been really relevant in the GraphQL community until recently, because Facebook, who invented it, have a pretty specific architecture that lets them fetch objects from a really sophisticated cached object store. And a lot of people are using it purely inside their organization. I think one place where it gets really interesting is also for public GraphQL APIs, right? Like GitHub announced a GraphQL API. If you're building your app on top of GitHub, like, and you want to use GraphQL for your UI, like what benefit do you get? Right now, unfortunately, the answer is not that much benefit. There's not really a great way right now to take a lot of smaller GraphQL APIs and combine them into one big one. But I think as more and more like backend services developers are interested in technology and there are more public GraphQL APIs, that shouldn't be a problem that's too hard to solve. Because definitely you have a description of the objects available in the API, and those you can just put together because there's one kind of object, there's another kind of object. The only thing that still needs to get figured out is what are the relationships between objects, right? If you had two different kinds of objects in two different backend services, the thing that's actually merging those schemas together will need to be able to introduce new relationships and new fields. And I think the only thing that's stopping people from doing that in a widespread way is literally just like syntax, and like nobody wrote the library yet, but you could do it.
So you talked about API layer compatibility in terms of an older client would ignore a newer feature because, hey, they know nothing about it. But what about in the reverse case where you have a newer client talking to an old API that doesn't have a feature it's expecting? How does that error, I'm assuming it's an error, I hope it's an error, and how does that error get propagated?
Yeah, the question is, I talked about how a older client that's only using a certain set of fields will be able to talk to a newer server that has a superset of those fields. What about the opposite case? If you have a newer client and you have an old server? So I think that would be an error. That would be a validation error in the query because those fields certainly don't exist. I think the technology is not really designed for that. I think the main reason that one might care about having old clients is specifically in the mobile application case, or any case where you're deploying a client somewhere far away and you don't have the ability to update it immediately, which most often happens with native mobile apps. And so the really common case is the client being a year outdated and the server being new. I don't think people have really investigated the use case of having an old server lying around, although that could totally happen in a case where you're somehow deploying the server onto customer infrastructure. But I don't think that use case is widely explored. I think one simple solution could be simply like return null for the features that don't exist, or build a client that does discovery. So one thing I didn't really mention is all these developer tools are actually built on an introspection system that lets any client of a GraphQL server go in and ask for which types the server has and what fields those have on them. So you could definitely build a client that would first introspect the server you have, determine what fields are available in there, and then only query the ones that are available. But that would definitely be a more sophisticated system than people are using today.
You talked about it being used as an API gateway, and you would effectively fill out the view layer of your MVC with the GraphQL. I wasn't entirely clear how the controller layer interacted with effectively the implementation of the GraphQL that would then make it back to the UI.
Which controller layer? On the UI or in the server?
In server.
The question is, how does the controller layer of the GraphQL query resolution work? So the thing you implement when you implement GraphQL is generally called a GraphQL schema. And I've been wanting to write this blog post for a long time. I haven't gotten around to it. But if you guys have used Rails, for example, or any REST API framework, you can think of the schema as the router. So because all GraphQL requests go to just one URL, like /GraphQL on your server, the schema is the thing that takes the different fields in your query and essentially routes them to functions that implement those fields on your server. And so essentially every type in your server becomes its own little controller that implements all these fields. And the fields might just be, fetch a bunch of rows from the database and just return that field. It might be, when this field is called, go fetch an external resource. So basically, yeah, you could think of each type in your GraphQL schema as its own little controller with its own little controller functions. And so really what you're doing is you're basically calling like a nested API that is executed in layers, or at least that's how most open source implementations work. There's also some pushes in the community to build a more sophisticated query planner that would be able to analyze the query ahead of time, and rather than executing a bunch of functions, actually like plan which resources to fetch from where to optimize it more. But that's not something that has really been publicized widely yet.
I guess two things. One short is, do the types allow for union types or variants?
One question is, do the types allow for union types? Yes.
Okay, cool.
And interfaces.
Second one, can you do a projection in the query language, like do a flat map? Take a nested data structure, flatten it out into sequences,
The question is, can you do different kinds of projection operations in the query language, specifically a flat map? One thing you can do in the query language is you can provide aliases to fields. So you can rename fields in the response, which is especially important if you want to query the same field twice, because then it would collide in the response. There's not much beyond that. However, most smart GraphQL clients operate by taking the GraphQL response and then flattening it out to store in the client-side cache and then deflattening it when they pass it back to the UI, mostly so that you can identify objects that are shared between different query responses so that you can cache them in the same place.
So most of the examples I'm seeing are all read operations. What does it look like to write through GraphQL, or is that not a possibility?
Yeah, the question is, most examples of GraphQL show reading data and not writing it. Writing data through GraphQL is indeed possible. They're called mutations. The reason people don't mention them much is honestly because it seems like that's not the focus of the system, which I think it basically isn't. The one really cool thing about mutations is, so a mutation looks exactly the same as a query. So like here's an example of a query. So you can look, in the query there's one root field here called human. If you were sending a mutation, instead of typing query over here, you would type mutation, and the root field would be the mutation that you're performing. So the really cool thing about mutations in GraphQL is you can actually refetch an arbitrary amount of data after you make a mutation. So rather than, in a post request, for example, you just get the new object that you created from your REST API. But in GraphQL, if you were to create a new object, that new object can actually be the root of an entirely new GraphQL query that can traverse as far as you need. Like you could update a post and then get that post and then like its comments, for example, if those were updated for some reason. But it's mostly like almost like an RPC mutation model where like the name of the field that you're mutating and the arguments describe entirely the operation that you're doing.
Most of the examples of GraphQL I've seen so far talk about dealing with single objects, like for example, human. What happens if you want to ask questions about calculations? Like for example, how many humans are there on the back end that patch a particular building?
Yeah, the question is, what if you want to do something more sophisticated than just fetching a certain set of objects from the backend? What if you want to do calculations? And I think that's where, so to put it really shortly, it's basically the same as you would do in a REST API. You pass some set of predetermined parameters that your backend has implemented, and the backend does whatever it feels like doing. GraphQL is not a language like SQL or something that might have a bunch of those operations built in. But one thing that's really cool about GraphQL is any field in your query can take parameters. So, as you can see here, let's say you wanted to get the height in meters, you would just change the argument on that particular field. So while there isn't a way of doing like filtering or calculations or aggregations in the language itself, once you've implemented those on the correct fields in your backend, it's really flexible how you query them, right? And this particularly applies to pagination, for example. Like let's say you're trying to, the Facebook common example is you have a news feed and then you might have comments. It's really easy to, for example, get the news feed and then for each post in the news feed, get the first 3 comments, because the comments field on that newsfeed post can take the arguments that specify how many comments you want, which is something that would be pretty hard to express in like a URL format where you would have to have some sort of nested parameters or something very similar to GraphQL. So it's critical that every layer of your query can have its own parameters that change how it's executed. Cool, thanks a lot. That looks like all the questions.